lesson is all about finding the surface area of 3D shapes with the flat faces. So things like cubes and cuboids and triangular prisms and pyramids, something like that. Something that would be a 3D shape without flat faces, plain faces, would be a cone or a sphere or a cylinder. We'll look at those in future lessons. Um, for things with flat faces, if you can visualize the net, or if you can at least sort of see all the flat faces, then surface area becomes a lot easier. So I'm just going to show you some nets unfolding. So here's a cube. So a cube means that all the faces are square. So it means that the length, the height, and the width are all the same. So if I open this cube up, you can see this has 6 different squares that make up the net. So the surface area of that cube would literally just be the combined area of all of those squares. And seeing as they all had the same area, it would be the area of one square times 6. So that's the cube. Here we have a rectangular prism, often called a cuboid. It's the same principle. It's still got 6 flat faces, but they're not necessarily the squares. One of the sides or more of the faces could be square, but they can't all be square because technically that would then be a cube. So all of these faces are rectangular. So if I unfold that, you can see that when we unfold the net, and this isn't the only net that would make that cuboid, but we end up with 6 different rectangles. So they're not all different. Certain way you can see that this rectangle has exactly the same dimensions as this rectangle. This rectangle has the same dimensions as this rectangle, and this rectangle has the same dimensions as this rectangle. So the combined area of those 6 rectangles, and area of rectangle being length times width, will be the surface area, so the area of the surface of the whole cuboid. So have a look at that. Okay, here we have a triangular prism. So a prism means it has the constant cross section going all the way through it. So if you see this triangle at the front, that same triangle, if you sort of cut this prism anywhere along it straight down, the shape that you can see would be exactly that triangle, the same size. That's what defines a prism, not the triangle bit, but the constant cross section. So if we look at the faces, hopefully you're getting to a point where you can see that you've got the surface is made up of triangle at the front, triangle at the back, a rectangle on the bottom, a rectangle on the right wall, rectangle on the left wall, and that's your 5 faces for this. If we unfold it, you can see all these faces. So you can see rectangle, 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 triangle, triangle. Now these 2 rectangles in this case have assuming these are isosceles triangles, these 2 rectangles have the same area. If it's not isosceles, they're not isosceles triangles, there's no reason for that to be the case, or equilateral triangles, it would work as well. But these 2 triangles will always have to have the same area. So the surface area will be the area of this triangle plus the area of this triangle plus the area of these 3 rectangles all added up. So it's the combined area of all the flat faces that make up the surface. And that wouldn't matter, say we had a prism and we messed about with the size a little bit, which we can do. So maybe make a sort of long, thin thing. It would still be made up of 3 rectangles and 2 triangles. Here's another shape, is a pyramid. So this is, I can't tell if that's a square or a rectangle. I'm going to assume that it's a square-based pyramid, but if it was a rectangle, you'd just work out the area of the rectangle. So this basically has a square at the bottom, and then it's got a point, in this case, above the center of that square, so a perpendicular line straight. And then you've got these 4 triangular faces. I can spin it. You've got 4 triangular faces. They all look like isosceles triangles, so 2 sides the same, 2 angles the same. And that is the surface. So you've got the bottom, which is this this square, and then you've got the 4 triangles. We could unfold that so you can see. Stop it spinning. If we unfold it, you can see you've got your square at the bottom plus 4 plus 4 triangles. And if you work out the combined area of all of them, it looks like for this that all the triangles have the same area. You can work out the surface area, e.g. the area of the surface. One final shape. This is a hexagonal prism, so you've got a hexagon at either end. It's kind of like a tube. And then you've got these 6 faces around the hexagon that are all rectangles. So it's similar to a triangular prism. It's just you've got more faces on the cross section. So if we unfold that, you can see you've got a hexagon. The flat faces are made up of 2 hexagons and 1, 2, 3, 4, 5, 6 rectangles, because you need 6 rectangles to wrap around the 6 sides of the hexagons. So that surface area, you need to, obviously you're going to get numbers and examples, but if you can visualize the net, or at least visualize the flat faces that make up these shapes, 3D shapes with plane faces, then surface area becomes quite easy. It just becomes a matter of finding the area of flat shapes and then adding them up.